Welcome to lesson 81, talking about using proportions to solve percentage problems. We're going to dive right into this as we cover this concept, as it's going to look familiar to many of the different techniques we've used to solve proportions. So, example 1 says 40% of the students at Lincoln Middle School do not buy their lunch in the cafeteria. If 480 students buy their lunch in the cafeteria, how many of the students do not buy their lunch in the cafeteria? All right, because this is a proportion type problem, we can set up a proportion box. Sometimes we call it a ratio box because they all have this relationship, and we can plug the information in that we know. We know some students are buying lunch, some students are not buying lunch, which gives us a total number of students available. Right? The other thing that we do know from our information is our 40% here of the students do not buy. So we can put that into our percent column here. And then we also know how many students do buy their lunch, that 480. And so basically we've set up all our information that is available for us. Now, if you look at this chart here, we might say, wait, there are way too many holes to be able to solve this. Except for we know this. We know that a total is going to be equal 100%. 100% of the students. And we also know that if 40% don't buy their lunch, that means that 60% must buy their lunch then, because 60 plus 40 has to equal 100. And so we have this idea. I can throw some percent signs in there just to make it look nice. Now what we have is we have proportional numbers that we can use to solve for our answer. Solve for the rest of the squares, rectangles, the rest of the chart. How many of the students do not buy their lunch in the cafeteria? And so what we want to do here is we want to set up the proportions as we see them. So with that information, we said 60%, right? We can put 60% over 40%. So buy, don't buy, and then we know that 480 do buy, so we want to know how many don't buy, right? Just like this. And at this stage, we're going to use cross multiplication and division to solve this problem, though we can reduce before multiplying if that works. So for example, I could just go into this and do 480 times 40 and get an answer, and then divide that answer by 60. Right? And you will get the correct answer. Right? You will get the correct answer. I, however, am looking at these numbers and I'm thinking I can do this in a simpler way. Right? I can take 10, divide both of these by 10. 60 divided by 10 is 6. 40 divided by 10 is 4. So I have that still common. I also know 6 and 4 can both be divisible by 2. And so in the end, I come away with 3 over 2 equals 480. Right? So this is actually what we would call the ratio of the percentages. And so I can use these numbers, this reduced fraction, to make my math simpler. Like I said, this process is still going to get you the correct answer. But now I'm taking 480 times 2, which is 960, and now I'm going to take 960 and divide by 3, which is going to be 320. And so I can then plug this in, and now I can say 320 students, I'm going to write studs for short, do not buy lunch. Right? And I can do one of two things now to get the total. If I needed that information, I could now add these two ideas together, or I could use proportions again to solve this problem. I mean, I'm just going to do the quick addition for a total of 800 students. So we have that idea. The box is filled. Now we can pull the information out of it that we need. Let's try another one. It says, in the town of Centerville, 261 of the 300 working people do not carpool. What percent of the people carpool? Right, so we got to break down the information again, right? We're going to have percent and actual in our chart here, and we're going to have carpool, don't carpool, and then of course a total. Now, of course, there are no percentages given to us other than the fact that we know that our total is going to be 100%. That's just a given. It's not physically, visibly present, but it is understood. Then from the information, we can say, okay, 260 of the 300 working. So 261 don't carpool out of the total of 300 people. So how many people actually carpool? Right? I can solve this right here real quickly just by subtracting 261 from 300 to get an answer of 39. However, it's not asking for the amount of people, but instead the percentage of people. But now that I have that information, I can quickly solve this. All right, quickly solve this. Looks like there's a part B to this problem. And I can set up the proportion. I have 100 over my unknown percent is equal to 39 over my known 300, like that. And so I have that idea. And from here I can now solve. So cross multiply says 100 times 39, so that would be 3900. And then 3 divided by 300 then, because it's going to be 300x. So I'm going to divide by whatever's left in this case. And to simplify this, I could think of this as a fraction, right? Because I could think of it like this. Right? Technically it's a fraction, so these zeros are going to go away. So I'm actually going to just cross these zeros out to make it a little simpler to understand what I'm doing. And 3 goes into 39 13 times. And the fact is that is going to be our percentage also, 13% of the total. And so I can do some quick math and get an answer of 87% do carpool. All right. If you didn't see that fast math that I did right here, you can go ahead and double check it on your own as you solve that for yourself. Now, a follow-up question. It says this: according to one national survey, approximately 13% of the working people in the U.S. carpool to work. Do these statistics reflect the national statistics? So as we look at our chart, does our chart agree with the national statistic that they're saying? Hopefully you're saying yes, because we also got 13% for our statistic. And so since that is 13% and they got 13%, we would say yes, they are in agreement. Your turn. Here's your sample, working with percentages and proportions to solve for an unknown. That's it for lesson 81.